Exams Vidhai is a non-profit initiative by the students of IITDM Kanchipuram. In this chapter, we shall learn about carbon and its compounds. In the earlier two videos, we've discussed about ethanol and hydrocarbons. In this video, we shall discuss about ethanoic acid, physical properties, chemical properties, uses of ethanoic acid, organic compounds, soaps and detergents. Ethanoic acid. Ethanoic acid or acetic acid is one of the most important members of carboxylic acid family. It has a molecular formula of C2H4O2. Its structural formula is this. Why do we call this as an ethanoic acid? Because it has the carboxylic acid functional group. Structure of manufacturing of ethanoic acid. Ethanoic acid is prepared in large scale by the oxidation of ethanol in the presence of alkaline potassium permanganate or acidified K2Cr2O7. This is potassium permanganate. When ethanol is reacted with K2Cr2O7 in the presence of H2SO4, because it is acidified potassium permanganate, we get acetic acid and water. We have discussed the mechanism of this reaction in the last video. Physical properties. Ethanoic acid is a colorless liquid having an unpleasant odor and sour taste. We know ethanoic acid is acetic acid and acetic acid is vinegar. Therefore, vinegar has an unpleasant odor and sour taste. It's miscible in water because we mix vinegar in water. Its boiling point is higher than the corresponding alcohols, aldehydes and ketones. Why is it so? Because of its complex structure. On cooling, pure ethanoic acid is frozen to form ice-like flakes. They look like glaciers, so it's called glacial acetic acid. Reaction with metal. Ethanoic acid reacts with active metals such as sodium, zinc, etc. to liberate hydrogen and to form sodium ethanoate. We shall first take one molecule and H is replaced by Na and sodium ethanoate is formed. But only H plus will be formed in that case. But H plus can't survive on its own in the atmosphere because it's unstable. Therefore, we take two molecules of ethanoic acid to form H2 gas. Similarly, in the case of zinc valency is Zn plus 2. Therefore, we are getting two molecules of this. Reaction with carbonates and bicarbonates. Ethanoic acid reacts with sodium carbonate. What is sodium carbonate? Na2CO3 and sodium bicarbonate NaHCO3, which are weaker bases and liberate CO2 with brisk effervescence. Let's take a quick review on how this is taking place. If we are taking CH3 C double bond O OH, that is ethanoic acid, on reacting with C double bond O ONA and ONA. Let's write this ONA with showing their bond. We know O is more electronegative, therefore negative and positive. Therefore, this will move out and we'll have like this. And now this H will be replaced by Na and we'll get H3C C double bond O ONA plus C double bond O minus ONA, and the same thing takes place again to form C double bond O plus H2O, and we get this as the final product with sodium ethanoate. Chemical properties. Reaction with base. Ethanoic acid reacts with sodium hydroxide to form sodium ethanoate. If we are taking acid-base reaction, we get a salt, and sodium ethanoate is a salt. Decarboxylation. What is decarboxylation? D means removal and carboxylation. Decarboxylation means removal of carbon dioxide. When a sodium salt of ethanoic acid is heated with soda lime is CaO. Sodium acetate is heated with sodium hydroxide in the presence of soda lime. We get methane and sodium carbonate. Uses of ethanoic acid. Acetic acid in lower concentration is used as a food additive, a flavoring agent and preservative. We know preservative and flavoring agent is vinegar. Ethanoic acid is used in the manufacture of plastic, in making dyes, pigments and paints, in printing on fabrics, as a laboratory reagent, for coagulating rubber from latex in the production of pharmaceuticals. Organic compounds in daily life. Raw materials from various important synthetic materials, fuels like LPG, petrol and kerosene, polymeric materials such as tire, plastic and containers, and where are alcohol used as solvent and antiseptic agent. We know isopropyl alcohol is used in tincture. Raw material for various important synthetic materials, aldehyde, formaldehyde, HCHO is used as a disinfectant raw material for synthetic materials. Ketone is used as a solvent and stain remover. Ether is used as an anesthetic agent and painkiller. Ester, all the cooking oils and lipids contain esters. Soaps and detergent. They contain surfactants, which are compounds with molecules that line up around the water to break the surface tension. What is surface tension? Sometimes we have seen mosquitoes sitting on water. How do they are able to sit on water? Because water has a thin layer that is called as surface tension, because all the molecules will be pulling the top layer tightly from bottom. Therefore, there is a thick rubber band kind of layer that is elastic where the mosquitoes are able to sit. Therefore, that is known as surface tension. Both of them having a different chemical nature. Soap is a cleansing agent that is composed of one or more salt or fatty acid. Detergent is a chemical compound or mixture of chemical compound. Why are we discussing about soap and detergent in organic chemistry? Because the hydrophobic part of soap is made up of hydrocarbon. Like all these places contain CH3, CH2. Therefore, we are discussing about soaps and detergent in organic chemistry, and they play a very important role. In soap, we have a sodium component, and in detergent, we have a sulfate and sodium component. Soap are sodium or potassium salt of long chain of carboxylic acid. If we see carboxylic acid group and sodium, long chain of sodium and carboxylic acid called fatty acid. Soaps require two major raw materials, fat and alkali. The alkali most commonly used in preparation of soap is sodium hydroxide, and potassium hydroxide can also be used. Potassium based soaps creates more water soluble product. The soap that we use in our day-to-day life is potassium hydroxide, that uses potassium hydroxide hard soap. Soaps which are prepared by the saponification of oils or fats. Let's discuss about saponification in the next slide. With caustic soda, what is caustic soda? Caustic soda is sodium hydroxide, NaOH, is known as hard soap. They are usually used for washing purposes. Soft soap. Soap which are prepared by saponification of oil or fats with potassium salt. That is, we are using KOH. They are known as soft soaps. So hard soaps uses NaOH and soft soap uses KOH. Manufacturing of soap. Kettle process. This is the oldest method but is still widely used in small scale preparation. There are mainly two steps followed. Saponification. In this process, we are taking an iron tank. Let's take this to be the iron tank. And we are having fat in it. And we are heating this. And we are adding alkaline solution. Let's assume that we are preparing hard soap. Therefore, 10% NaOH is added and we are heating it, and all the steam are collected, and then at the end we are adding NaCl for them to precipitate. So we get a thick layer here like froth, and we remove them, and that froth is dried up to form soap. So saponification and salting out is used to prepare soap, and the precipitate is allowed to cool down. Effects of hard water on soap. In soap, we've seen that the hydrophobic part contains a sodium one at the end. And if we are using in hard water, it contains calcium and magnesium. This sodium will be replaced by calcium or magnesium. That limits the cleansing action of soap. When combined with soap, hard water develops a thin layer precipitation of metal ions. This Na will get precipitated, called as scum. Scum is like a grease-like one which leaves a deposit on the clothes or skin and does not easily rinse away. Over the time, this can lead to deterioration of the fabric, like the fabric may become old or it may get torn and eventually ruin the clothes. On the other hand, detergents are made with chemicals that are not affected by hard water. Ordinary soap, when treated with hard water, precipitates a salt of calcium and magnesium. They appear on the surface of the cloth as sticky grey scum, thus the soap cannot be used conveniently in hard water. Detergents. These are salt of sulfonic acid or alkyl hydrogen sulfate in comparison to soap, which are salts of carboxylic acid. It is a salt of alkyl hydrogen sulfate. The detergents do not form precipitate with Ca2 plus and Mg2 plus present in hard water, so the cleansing action of detergent is better than that of soap. Preparation of detergent. We know that soap is prepared by saponification and detergent is prepared by adding sulfuric acid to the processed hydrogen carbon obtained from petroleum. This chemical reaction results in the formation of a molecule similar to that of the fatty acid in soap. Then an alkali is added to the mixture to form the surfactant molecules which do not bond with the minerals present in hard water, thus preventing the formation of precipitate. Ingredients. In addition to surfactants, the modern detergent contains several other ingredients. Sodium silicate. Na2SiO3 is sodium silicate, which prevents the corrosion and ensures the detergent does not damage the washing machine. Fluorescent whitening agent that gives glow to the clothes, like we use a liquid called blue, which gives a white color to the clothes, and oxygen bleaches such as sodium perborate. NaH2BO4 enables the removal of certain stains from the cloths. Sodium sulfate is added to prevent the caking of detergent powder. What is caking? To form lumps. Like they form all bubbles in the soap. Like the soap powder itself will become a mold or a bubble. Enzymes are added to break down some stains caused by biological substances such as blood and vegetable juice. Certain chemicals that give out pleasant smell are also added to make the clothes fragrant after they are washed with detergents. A soap molecule contains two chemically distinct parts that interact differently with water. It has a polar end, which is a short head with a carboxylate group, and one non-polar end with a long tail made of hydrocarbon chain. So this is the hydrocarbon chain, non-polar end, and this is the polar part. The polar end is hydrophilic in nature and this end attracts towards the water. This is the polar end and this is hydrophilic and this attracts towards water. The non-polar end, hydrophobic in nature, attracts towards dirt. If there is a dirt, the non-polar end attracts here and the polar end makes it soluble in water. When a soap or detergent is dissolved in water, the molecules join together to form micelles. So it forms like this, like this, like this, like this. Their long hydrocarbon chains attach themselves to the oil and dirt. The dirt is thus surrounded by the non-polar end of the soap molecule. Therefore, the dirt is always surrounded by the hydrophobic part and the hydrophilic part is surrounded by water. The charged carboxylic end of the soap molecule makes the micellase soluble in water, thus the dirt is washed away. Therefore, this makes it soluble in water. Like here we see the hydrophobic part is attached to the dirt and the hydrophilic part is towards the water. And this is called micellate. Advantages of detergent: can be used in both hard and soft water and can clean more effectively in hard water than soap. Can be used in saline and acidic water. Do not leave any soap scum on the tub or tubes. We've already discussed that Detergents have this sulfate part because of which they do not form any scum and they do not react with calcium or magnesium. Dissolves freely even in cool water and rinse freely in hard water. Can be used for washing woolen garments. Have a linear hydrocarbon chain which are biodegradable. Do an effective and safe cleansing, keeping even synthetic fabrics brighter and whiter. Disadvantages: some have branched hydrocarbon because of which they are non-biodegradable and they cause water pollution and they're relatively more expensive than soap. Biodegradable detergents, they have straight hydrocarbon chain, and non-biodegradable detergent, they have branched hydrocarbon chain. What is TFM? Total fatty matter is one of the most important characteristics describing the quality of soap. If the TFM is more, the quality of the soap is more. Like bathing soaps have around 70 to 80%. And if we see all the soap boxes, we have the TFM written in it. This is defined as the total amount of fatty matter, mostly fatty acids, that can be separated from a sample after splitting with mineral acids. What is the difference between soap and detergent? We've already discussed them. Let's just tabulate them. They have sodium salt of fatty acid. They have sodium salt of sulfonic acid. The ionic part is COONA and the ionic part is SO3Na. They are prepared from animal fat or vegetable oil. They are prepared from hydrocarbons. Its effectiveness is reduced when used in hard water. Its effectiveness is even used in hard water because they don't react with calcium or magnesium. They form scum in water. They do not form scum in hard water. They have poor foaming capacity and they have rich foaming capacity. Soaps are biodegradable and detergents are non-biodegradable. For more videos, stay tuned. Thank you.